Welcome. You are in the webinar hosted by Built Green, titled Mastering Built Green, our Washington State Energy Code 2021 residential code changes and cost-effective HVAC strategies. Hopefully you're in the right place today. And just to cover some basic groundkeeping rules, we will be running at least the presentation at least until about 1:15. All questions can be entered into the chat throughout the conversation and the presentation. We will be monitoring them for any sort of burning definitions that need to be addressed or comments that might need to be addressed first, but the majority of questions will be addressed at the end, where we will have a more thorough Q&A section. And should you have any difficulties, Ashley has entered in the chat some technical information for you in case you're having issues connecting or having sound issues. She can help you out. And lastly, we will be sharing this recording as well as the slides from this presentation following the event within about 1 to 2 weeks once we process the video. And so you'll have that. So take as many notes as you want, but you will be receiving the slides later. And lastly, I will introduce Greg Davenport of Mitsubishi Trane Electric for hosting and presenting for us today. And Greg, I will let you take it away.
Thanks, Sonia. I'll start by introducing myself, and then I'll go into a few quick housekeeping things that Sonia didn't touch on. I probably know some of you on the call. I haven't looked at the list yet, but I work with a lot of builders in the area. 2007, I started working on energy efficient lighting programs in the Seattle area for all 4 of the major metropolitan utilities: Puget Sound Energy, Snohomish PUD, Tacoma Power, and Seattle City Light. Did that for 6 or 7 years until we had some code changes. And then I worked for a year on a regional high performance home program for NEA, where I worked with a lot of builders in the region, helping them figure out how to build net zero ready homes. So I got to know a lot of builders in the region and a lot of building science. Took off to Asia for a little while, came back, and Mitsubishi had this really cool job they call performance construction. We're basically a team of about 7 people around the country that help high performance builders figure out how to use and succeed with high efficiency heat pumps. It's a great job. About 3 years ago, I looked at the 2018 Washington State Energy Code and realized that it was a big tailwind for high efficiency heat pumps. Started talking to my friends at Washington State University, Mike Lubliner, said, hey, can I go out and do some code training for people on the heat pump stuff so we minimize the growing pains into the new code? And all the people I knew at WSU said, yeah, that's great. And I did it for a couple of years. And then Mike at WSU said, hey, would you like to participate in the next code making process? And I got involved in the Washington State Energy Code Tag Group, which I've done over the last year or so. And it's been really professionally a rewarding process. And I'm also out there doing a lot of code training on the new code now to help people minimize the growing pains into heat pumps and the rest of the new things that are coming with the code. I will focus probably 60% on high efficiency mechanical systems for homes. I know a good amount on the other building science issues that are coming in the new code, so I will also talk about those. Normally when I do this training session, it's about 50, 55, 60 minutes, depending on the audience. Sonia and I talked about this. We want to go a little slower today so we can take a little deeper dive. Afterwards, there will also be an extended Q&A, so put your questions in the chat box. Looking forward to answering those. Sonia and I also talked about some of the 3-story, 4-story townhomes that you see around Seattle are pretty challenging for mechanical design and other design, even under the current code. So when we get to Q&A, we may also take a few minutes and talk about issues with townhomes under current code. Everything that we can sort of learn how to do right under current code will also help us with new code for those tricky townhome projects. Okay, the last thing I wanted to say before we launch into the presentation is when I do this training, I am largely brand neutral. I'm not perfectly brand neutral, but most of what you see in this training presentation applies to all the high efficiency heat pump manufacturers. There are only 2 or 3 slides that are kind of Mitsubishi specific. I will also talk about some other brands, and you'll see a few pictures of other brands out there. Okay, let's go ahead and get started. I do this code training presentation all over. We want people to be ready for the new code and be comfortable with it. There are some big changes coming under this code, but it's not as bad as people think. When in doubt, always refer to the State Building Code Council website and read the Washington State Energy Code for definitive answers. If you can't find definitive answers there, you can consult with your local code official. Also, WSU has a great code hotline, and they can help with a lot of questions too. We're going to talk about the 2021 code. For now, we are still operating all the permits pulled under the existing 2018 code. The new code was scheduled to go into effect on July 1st of this year. There has already been one delay till October 29. Most larger builders do their planning for projects at least 6 months out. So really builders need to start gearing up for the new code now. But remember, until this code becomes implemented or whatever date you pull your permit, you're still operating under current code. That will probably change later this year. It's possible we'll get another delay, although this delay was a pretty big one. We typically do get delays with code implementation, so that did not surprise me. The official language for the code is available on the State Building Code Council website. It's a great resource. So one of the really important concepts, Washington probably has the best new construction codes in the country. And as we adopt more energy efficient codes to meet the state's energy and carbon goals, which by the way, the state has really mandated. So our aggressive energy codes are how the state is going to meet those goals for energy and carbon. But when you look at home building for the last 15 years or so, every 3 years we get a new code cycle that comes down from IECC. And on this graph here, you see a HERS score. You don't see a lot of HERS builders here in Washington, but it's like miles per gallon. And it's a pretty good way to measure energy efficiency of a home. You can see that the 2018 IECC is basically, and we're now moving to 2021 IECC, we are right around the net zero ready level. And I will tell you that Washington code has some enhancements above and beyond 2021 IECC. So our code pretty much is getting builders to that net zero ready level, which is why you see them encouraging solar panels and all electric homes. This graphic you see here is probably 2 or 3 years old. It talks about variable capacity heat pumps, and I'm going to use some synonyms today. So let me go ahead and explain that right now. Variable capacity heat pumps means an energy efficient heat pump that modulates its speed from about 20% to 100%. We know them here in the Northwest originally as ductless heat pumps. I sometimes will call them high efficiency heat pumps. There's a lot of different names out there, but in general terms, when we say variable capacity heat pump, we mean variable speed, energy efficient heat pump system. High efficiency heat pumps are the dominant technology around the world. You can see here the adoption rate. In North America, currently it's probably about 15, 16, 17%. If you updated that number, Washington State is way ahead of the rest of the country in North America. You'll see in a couple slides, are actually under our current code, which already encourages heat pumps for both space conditioning and hot water. We're over 80%. And I'll give you the data here in a few slides. So when I hear builders and other people saying the new code's too aggressive, we can't do it, I'm not buying it. We're already over 80% of the way there for heat pumps for space conditioning and hot water in Washington State. So getting to 100%, that's not a big gap to close. All right, I'm going to cover some fundamental stuff on heat pumps here just to make sure everybody's kind of on the same page. One of the good things about heat pumps is they provide both heating and cooling. They are variable speed. So if you can imagine buying a car that only went 70 miles an hour and having to drive that, through the city and all over town, that would not be very efficient. And that is kind of the way first generation heat pumps were. We've come a long ways with heat pumps, both in terms of their ability to modulate and also their ability to deliver energy efficient heating in cold climates. The most important thing you do when you push for energy efficiency in a home is build a good envelope. Right after that, you go for good mechanical systems. Heating and cooling systems use, depending on the home, 30 to 40% of the energy in a typical home. So it's kind of where you get the most bang for your buck when you're looking for high efficiency homes. Historically, 10, 15 years ago, heat pumps did not do very good when it was cold out. And a lot of people who aren't keeping up with new generation heat pumps still think heat pumps don't do well when it's cold. That's just not true anymore. And we'll talk a bit later about cold climate heat pumps because the new Washington State Code is really encouraging people to use good cold climate heat pumps where they need them. If you use a good cold climate heat pump and design it right, you probably will not need supplemental heat. Variable capacity heat pumps or high efficiency heat pumps are a major milestone on the path to net zero homes and strategic electrification, which is why they fit well into the plan for Washington State and a lot of other areas where they're pushing for sustainable home building. So just like we saw the HERS score coming down lower and lower and lower all the time, or homes built under newer codes that are more energy efficient, the same correlation is true for heating and cooling in homes. Homes used to, on the average, have, in HVAC slang, we say ton. 1 ton equals 12,000 BTU of heating or cooling. So used to be 20, 30 years ago, every house they built was a 4 or 5 ton house. We have come a long ways, building better envelopes and more energy efficient homes. Most homes in Washington State now are under 3 tons. We see a lot of homes that are in that 20 to 30,000 BTU range for heating and cooling, which is one of the reasons why variable capacity heat pumps really are a good fit. Another thing that's very important is heat loads for winter get lower and lower and lower as you build a better envelope. Cooling loads are partially driven by the outdoor air temperature and partially driven by internal gains, cooking, human beings, lighting, computers, bathing, hot water, and things like that. So we are seeing in Washington State heating loads getting lower and lower and lower as we build better. Cooling loads, however, are not coming down as much. We are starting to see more and more homes where the cooling is close to the heating. And in some projects where you have glass that faces south or west, you may actually have higher cooling loads than heating loads. And that is a big change in terms of how we have to do HVAC design. Washington State has that state worksheet for doing heating loads that is kind of a whole building heat load. It's an okay start, but it is not really a great way to do HVAC design. I encourage builders and HVAC contractors to do what's called room by room heating and cooling loads. It's very important in terms of reducing the comfort complaints that you get in homes. If you're a builder out there, you really want to be talking to your HVAC contractor about the new codes and how you want to get there and finding the most cost-effective way to do that. I have more and more builders that are finding their HVAC contractors are not giving them everything they want for good HVAC design. And some of those builders are moving over to what we call third-party HVAC design. If you're interested in that, we can talk about it in Q&A. I've got 4 or 5 different third-party HVAC designers I use in the Pacific Northwest, and I can make some recommendations for you there. I actually have a builder in North Idaho who moved to third-party HVAC design, discovered that their HVAC contractor was adding a big safety margin in, and we were able to right size their HVAC designs and save them about $1,500 on every house. So really good HVAC design prevents comfort problems, and it's also a good way to value engineer without sacrificing comfort. We talked about all of that. One of the great things on variable capacity heat pumps like Mitsubishi and others make is you've got a lot of different options for getting the heating and cooling distributed inside the home. Up here you can see, and I'll try and hover my cursor, that's your traditional ductless wall head. We've come a long way since we started with those here in the Pacific Northwest. In the top middle here, you've got what we call a 4-way cassette. We make them and others make them. They're okay. You see them a lot in commercial buildings, but we have a better solution now that you'll see in us. Well, we'll just move to that now. Down here in the lower left-hand corner, you see what we call a 1-way cassette that is flush mount. So people who have issues with the aesthetics of the ductless wall heads love these 1-way cassettes. We have a lot of builders moving to those. This here, well, you can see down on the bottom here, that is a traditional multi-position air handler that you can attach to a variable capacity heat pump. And we are moving a lot of builders to that. You'll see some examples of that in a couple of slides. Up here is an option that builders don't utilize enough, in my opinion. We call it a horizontal ducted or a slim ducted system. And you'll see a good example of that in a couple more slides. Over in the upper right-hand corner here, we call that a floor mount. I don't see that a lot in residential new construction. The one place you do sometimes see that type system used for indoor heating cooling distribution is historical retrofit projects where you used to have the radiators. Pretty easy to replace with this, and it's a much more energy efficient heating and cooling solution. So I know some builders have heard about this, but under the IRA, there are some big incentives available for high performance home builders out there. I've talked a lot with Sonia about this, but Washington State Code, most builders, I think, if they do a checklist with a verifier, will be able to get to the Energy Star home level. It's very, for most builders, I think Washington State Code meets or exceeds the Energy Star level. So it shouldn't be too hard if you work with a verifier and do a checklist. A lot of Washington State home builders are probably pretty close to the DOE Zero Energy Ready level. And if you do that, it's $5,000 worth of incentive money, which is a lot of money. Same thing when we get to Q&A towards the end. If you want to talk more about this, how to find a verifier who can help you get that incentive money, I'm happy to talk about it.
Yeah, just to interrupt.
Yeah.
For anyone going after Built Green certification, Energy Star is pretty much a given. Like Greg was saying, that's essentially code. The Department of Energy Zero Energy Ready is very applicable to high performing 4-star projects and all projects seeking 5-star. There are some things that the reason it's a high performing 4-star that would kind of qualify is there are some additional things that go above and beyond what is the standard kind of 4-star formula, but you can achieve the Zero Energy Ready certification with a 4-star project.
And more verifiers in the Pacific Northwest are realizing with all the new IRA generous incentives, they need to help builders get this. So talk to your verifier about, how close you are currently and what it would take to get there to see if you can get this incentive money. We have a lot of great verifiers here in the Pacific Northwest, and they're all good at this. I'm going to ask a favor of the group here, since I'm going to keep going with the presentation, but some of the material that I talk about, because there are some changes on the R2 low-rise multifamily, and I want to have a better understanding how many people in the audience here are doing multifamily projects. If we have more than 1 or 2 builders, we may take a little deeper dive on that. So if you are a builder or somebody listening in who gets involved with multifamily projects, will you please put something in the chat box? And then after a minute or 2, and people have to time to respond in the chat box, Sonia, if you can let me know, that would be great. Actually, I could probably open the chat box here. Yep, I can see the chat box here now. I'm going to close the chat box. Maybe after a minute or so, Sonia, if you can give me an idea of how many builders are interested in multifamily material, that would be helpful.
Yeah, it looks like we have 3 so far and 4. So 4 so far, 5,
Great.
6.
Good. If we had no multifamily builders, we would go quickly through that. Since we have more than a few, I'll make sure everybody, we don't skip any of the multifamily stuff. So this is a great builder down in Oregon, here in the Portland area. I'm in Vancouver, Washington right now, but worked with them for a long time. They're doing the Earth Advantage Net Zero Ready certification down here, very similar to the Built Green programs up in Washington State. And I wanted to show you some cool things they do and how this would actually work in Washington. So this builder's been doing Net Zero Ready for probably 3 or 4 years. They get good incentive money down here in Oregon for doing it. That is what one of our high efficiency heat pumps looks like. Looks an awful lot like a traditional furnace, but it gives you both heating and cooling. And most of this builder's homes are 2-story homes. You'll see a picture of it in a second. They use open web trusses. I know in Seattle and all over in Washington, we have a lot of 2-story builders. I'm seeing more and more builders move to the open web truss design because it makes the ducts inside conditioned space easier. It makes moving that air handler. You can either go upflow downstairs or downflow from upstairs and get all of the ductwork inside conditioned space. These homes for this builder, nearly all electric homes. The only thing they didn't do is they use tankless gas hot water heaters, and it's mostly because the gas utility was giving them free gas. I think in Washington, that's going to be changing for a lot of builders. So that'll be a different dynamic up in Washington. And this is what the open web trusses look like with ducts inside conditioned space. These are pretty big homes, but because they're building really good envelopes, they have, I think all of their homes are 2.5 or 3 ton systems. So it's a pretty small heating and cooling system because they have low heating and cooling loads with a great envelope here. And you can see how easy the ducts inside conditioned space is. That ductwork system there, in the ceiling downstairs, they have the supplies for downstairs. In the floors upstairs, they have the supplies for upstairs. If you built this very same home in Seattle, under our new code that's coming, this would get you 3 out of the 5 points you would need. And the way this breaks down is you get 1.5 points for fuel normalization, you get 1 point for the 11 HSPF heat pump, and a 0.5 point for ducts inside conditioned space. We can see in Washington with the data that most home builders have already gone to the high efficiency heat pumps and heat pump water heater systems. It is the least expensive way to get the energy credits under the Washington State Code. So this is a little different approach that I think will work well for some builders. You can see over here, and I'll kind of hover my mouse there. That's the one-way cassette. And if you put that in the great room, you can eliminate a ton of ductwork in a home. The right side here in this image, you can see what we call a slim duct system. That's about 20 or 25 feet of little trunk line and a soffit ceiling serving all the bedrooms in this Rambler house. And then they have little branches going into each of the small rooms. So by using this strategy, this house has probably eliminated 65% of the ductwork. And I was down here in the Portland area about a month ago with a builder and their HVAC contractor, and we looked at a home where they'd use this strategy. I looked right at the HVAC contractor in front of the builder and said, hey, if you did this for this builder, by reducing all this ductwork, would it be a less expensive system? He said, yep, I'm pretty sure I'd charge them less money by eliminating all that ductwork. So this is one of the great reasons to look at all the different options with variable capacity heat pumps, figure out ways to value engineer it and reduce ductwork. The other thing in Washington that's great about this strategy is under our new 2021 code, this would actually be a 3.5 point option. You get 1.5 points for fuel normalization, and then you would get 2 points for using the 10 HSPF multi-zone ductless heat pump system. So I talked earlier about how far we've already come in Washington State getting to heat pumps for space conditioning and hot water. This report is now about, the data in here is probably 1.5 years old. The report was published just a little over a year ago now by NEA. And they went out and did research of new construction permits for residential. And they also did builder surveys to find out if the permits matched reality in most areas. What they found is heat pumps for space conditioning are already being used almost 88%, actually 88% of the time in Washington State. And we're slightly over 80% heat pump hot water heaters already. So getting to 100%, which is where the new code's trying to take us, is not really a big stretch from where we're currently at. Okay. Shifting gears slightly here, R2 low-rise multifamily. Generally, R2 low-rise multifamily is 3 stories and below. There's, under the new Washington State Code that's coming, there's an important distinction that multifamily builders need to pay attention to. On the lower left side here of this slide, you see a low-rise 2-story multifamily building with all of the access to the apartment units on these long exposed corridors here. That was affectionately referred to on all the code discussions as woody walk-ups. I kind of like that name. Those low-rise buildings where you have exterior access to all the apartment units can continue to go under the R2 low-rise multifamily code path. If you have a low-rise R2 multifamily project like you see over in the lower right-hand corner here, where the entrances are enclosed with a corridor, under the new code, that's going to have to go under the commercial codes. So that will be a change for some multifamily builders. The next interesting bit here, if you're low-rise and you prefer to do commercial code, you are allowed to go under that pathway. But you can take either. Enclosed corridors for the entrances, you have to go into the commercial path. Similarly, if you're R2 low-rise, whether you're enclosed corridor for entrances or outside corridor for entrances, you can go either path for hot water. The R2 single family or the R2 multifamily. Commercial code, sorry. Commercial code is also going to be requiring heat pumps for all the hot water in all the commercial buildings going forward. So this is a big change under the code. Used to be that heat pumps were encouraged with energy credits, but not required for hot water. Under the new code, heat pump water heaters will be required in most homes. There's one important exception we'll get to here in a second. Number 3. So if you're building small apartments or small single family homes under 1,000 square feet and you don't want to do heat pump water heaters, you don't have to. That's not going to affect too many folks. The other thing you're going to see when we get into the energy credit tables here in a minute is heat pump water heaters are also one of the best values under the new code to get energy credits. Most builders will be doing heat pumps for space conditioning, heat pumps for water heaters. And unless you're doing a very large home, that will probably give you all the points you need. These are the package heat pump water heaters. They're great. They've been around for a long time. I will say we pioneered them here in the Northwest. That may not be entirely true, but what I will say is NEA, with their qualified product list for energy efficient heat pump water heaters, that's kind of the gold standard to make sure you're getting a good energy efficient heat pump water heater. Most builders try and put these in garages or other unconditioned areas. That is the ideal location to do these installations. If you have to put them inside of conditioned space, you want to make sure you get a ducting kit on there because they discharge cold air. I do want to talk for 1 second about multifamily hot water systems. You'll see this a little more in a couple of slides here. But if you're doing a low-rise multifamily and rather than having hot water tank in each apartment unit, you don't want to give up that space and you want to go with either centralized or semi-centralized hot water systems, which we've seen in a lot of, not a lot, but we've seen it in some Seattle area multifamily projects. As long as it's an equivalent or better system, the code does allow for you getting those credits. You want to make sure you talk through that with your code official and they understand where you're going. But you might have a 10-unit apartment building where you want to do a centralized heat pump water heater system. And as long as it's the same or better energy efficiency, you should be able to get that credit. These are the Sanden heat pump water heaters. They've been around for a long time. We pioneered them here in the Northwest. They're great. They're a little more expensive than the package units. Most new construction home builders are using the package units. We see these in high-end custom homes though. One great thing about the Sanden systems, and these are made and sold all over the world. We also make a similar system that we sell in many parts of the world. They use CO2 for refrigerant, which is great for heating, not as good for cooling, but that's a better refrigerant. Because of the new requirements in Washington State under the commercial code, Mitsubishi's been making this, excuse me, large commercial heat pump water heat system for commercial and multifamily buildings and selling it for, I understand, about 10 years around the world. We are bringing this into Washington. I know we've got quite a few projects going in Washington and Oregon now. Some of you may know Bayview Towers down at the base of Queen Anne. It's a care home that's been there for a long time. They had old electric resistance hot water tanks. And about a year and a half ago, we put these systems in there, much more energy efficient, and replaced the old electric resistance hot water tanks. Okay, shifting gears from hot water here. Some of you may have heard that under the new code, if you follow the prescriptive path, continuous exterior insulation will be required. You can see it here. I'll put my cursor kind of hovering that little section there that's relevant. And yes, if you follow prescriptive path in Washington, they're telling you you should be doing continuous exterior insulation. There's a but here. If you can do what's called a UA trade-off calculation, which is like an energy model, show that you have a equivalent or better wall, you do not have to do it. And we're going to talk about that. Here's a builder. This is Habitat Tacoma. I've worked with them for a long time. They're fantastic. Many habitat affiliates use the continuous exterior insulation. It's that blue foam you see there. It is a great choice for an energy efficient envelope, but it is a little bit expensive. So here's the alternative path. If you can do a good envelope that meets or exceeds the code minimum wall, you're not required to do the continuous exterior insulation, but you do have to do the worksheet and prove that your wall is meets or exceeds the code. And what you are going to find is it's going to be advanced framing, maybe raised heel truss, or something like the double wall staggered stud you see over here on the left side. This lower right side wall, not necessary. I've had a lot of conversations with builders and with verifiers who do the energy modeling. Most verifiers, even WSU, believes that if you're doing a good advanced framing wall, doing good insulation, you're probably going to be able to get out from having to do the continuous exterior insulation. WSU is getting ready to release their worksheet. Verifiers can do this envelope calculation. If you're using a verifier, talk to them about how they can energy model your wall and see if you're going to be able to get around using that exterior insulation. The great thing about advanced framing, though, is you're actually using less wood in the walls. It's less framing labor. I found this case study down in Oregon here. It's a very recent case study, and I thought it was pretty interesting. We all know how lumber prices got wacky about a year and a half ago, and it was freaking builders out. The lumber market did settle down, but advanced framing actually reduces the lumber in walls by up to 30%. Single family 1 and 2 story homes may be a little different than the 5-story multifamily project you see here, but advanced framing, once you get the hang of it, is a good strategy. I think most builders would be rewarded by doing that. It also will cut down on your thermal bridging, make it easier for you to avoid having to use that continuous exterior insulation. Better Built Northwest is kind of a coalition sponsored by NIA and a lot of other allies in the region here. They have some great training tools on advanced framing that you can get for free on their website. So because the new code is going to require better envelopes, heat pumps for space conditioning, and heat pumps for hot water, we actually have reduced the code points required, energy credits, under the new code here. And you can see small homes go from 3 credits required to 2.5. Medium homes go from 6 down to 5. Large homes go from 7 down to 6. Multifamily stayed the same at 4.5. But when you look at multifamily, if they just use good heat pump systems for space conditioning and hot water, most of them will be able to get the 4.5 credits they need and they're done. So most of these pages here where I've got the code tables and some of the other code citations, this was the CR 103 that was out there. I have my page references in case you want to look at the details. And I do encourage people to look at the details in the code and make sure they're getting all the fine print. So under new code, heat pumps are going to be required for space conditioning in most residential new construction. There are 8 exceptions here, but they are not going to apply to most buildings. Fuel normalization table, we had this under the old code. There are some changes to it under the new code. Let's kind of break this down and talk about it. There's only 3 here that I think are going to be common. There are 2 here that are going to be pretty uncommon. So if you fall under one of those 8 exceptions you see here, and you can do heat pump space conditioning, which will not be common, then you get -3 if you use combustion heating system here, if you're allowed to. That's probably not going to be appealing for most builders. System type 2 is pretty new. Yeah.
Just a quick clarifying question. Somebody asked about additions less than 500 square feet.
Yep.
They asked, have they dropped from 3 to 2 credits required? Just to quickly go back to your credits.
So I don't focus much on additions. My main focus is with builders for new construction, and I don't track the remodel and the additions very much. I am not sure on that one.
Okay,
I know that additions and remodels are tricky. I think as long as you are doing your best to meet the letter and the spirit of the code, most code officials are reasonable about that, but the code officials always have the last word. So back to fuel normalization here. System type 2 is new compared to our old code. If you use a heat pump system and you need supplemental, you're going to get 0 energy credits. Compare that to system type 4. System type 4 is if you're using a heat pump without supplemental for all of your space conditioning. And we're going to talk quite a bit about cold climate heat pumps as we move along here. The state is basically saying, hey, cold climate heat pumps avoid supplemental and give you energy efficient heat pump heating and cooling. That's the direction they want everybody to move. So most builders, to get that 1.5 energy credits plus the high efficiency credits for the heat pump system, this is what they're going to want to do. System type 3, I don't know any builders that are using all electric resistance anymore or electric resistance forced air. So that's not going to be very common. System type 4 is going to be the most common going forward. There will be a few growing pains with builders and HVAC contractors to figure out how to avoid supplemental. It is totally doable with a good cold climate heat pump and good HVAC design. System type 5 has been in Washington code for a long time. It's a great option. I've got a couple of big builders that do it now. You put the mini split in the largest living area and then electric resistance in all the other bedrooms. You get a half credit for fuel normalization. And when we get into the high efficiency HVAC options, you'll see it's another point or 1.5. So it's a great option. One interesting thing to consider on this, I've got a big builder that does townhomes up in North Seattle, and they put a mini split in the largest living area. They put a mini split in the master bedroom, so there's heating and cooling in there for the homeowners that are paying the mortgage. And then the little bedrooms where the kids are kind of on the middle floor that get the heating and cooling drifting up or down with stack effect. They don't worry about that, and they do electric resistance. Very good value code path. So these options were in the old code. I don't know if the points have changed any. This first tier of envelope upgrade, U.22 windows used to be 0.25. The 0.25 windows you can get in double panes. 0.22 is going to get you into triple panes. And there's a new generation of windows coming called the thin triples. A lot of people are excited about them because they'll be pretty low cost upgrade to get a significantly better window. So if you can do good U.22 windows, there's a half point energy credit available for you. The other option that's interesting here is if you can do U.25 windows, which is double pane and low insulation upgrade, you can get a half point. But I think those who do that UA trade-off calculation are probably, many of them will be able to qualify for this credit. So you kind of get a bonus if you do this credit here with being able to avoid the continuous exterior insulation. The bottom two tiers you see on this table will not be common for builders. With the exception of builders who are maybe shooting for 5-star built green, those builders probably will hit this third tier here. The bottom tier is like passive house tier. Okay, high efficiency HVAC credits. If you are allowed to do combustion heating system here and you can do a high efficiency one, you can get 1 credit back. You lost 3 under fuel normalization, you can get 1 back for using a high efficiency gas furnace here. The other option using gas under our new code is If you're gonna have supplemental, which I don't think many builders will for their heat pumps, but you get a high efficiency supplemental system, then you can get a half credit here. The two options or three options for high efficiency HVAC credits that are gonna be most common for builders will be this 3.3, 9.5 central heat pump, which we've seen under the current code for the last 2 or 3 years. That will still be very popular for builders. The one twist on this is, if you're in a colder area, which is mostly outside of Seattle, we'll talk about that in a few more slides, and you're going to use a heat pump to claim these credits where your design temp is below 23, you have to use a NEEP certified cold climate heat pump. We're going to talk more about that. Seattle area, though, many parts of Seattle are 24 or 25 design temp. So Seattle is really going to be right on the bubble. I don't know any builders using ground source heat pumps, so I don't talk much about this, but that is still an option for an energy credit. So if you get the half point for fuel normalization here, and then you take option 3.5, which is going to be the 10 HSPF or better ductless mini split in the largest living area and electric resistance everywhere else, that's 2 points in single family or 2.5 points in multifamily. For some builders, that's going to be a pretty cost-effective path to go down. The 11 HSPF option that we've had under the current code that a lot of builders have been moving towards will still be there and get you a credit. So that's going to be a very popular option. Same thing as the 9.5 HSPF heat pump. If your design temp is 23 or below, you need to use a good cold climate heat pump to get that credit. This will help builders avoid strip heat by using the good cold climate heat pumps. Cold climate heat pumps cost a little more, but then you don't have to do the strip heat and the strip heat lockout, and the utility bills are lower because they're more energy efficient systems without the electric resistance strip heat. 3.7 is going to be a popular option for some builders. We've had this under current code, but if you use a multi-zone mini split system, 10 HSPF or better, you get 2 credits plus 1.5 for fuel normalization. So that's a great option under the code. We saw under current code a lot of the Seattle area townhome builders who were trying to get built green points and also get this 3.7 credit. When you get to these energy efficient townhomes you see in the Seattle area that are built green certified, a lot of their heating loads are 24,000 BTU and below. And in these smaller multi-zone systems from all manufacturers, you see lower HSPFs. So we had some sort of perverse things happening where we had builders that were getting forced to use 2 and 3 single zone systems in their townhomes to claim these credits. And I took a look at that when we were going through the code making process and suggested that if you're building a small sustainable townhome where you have a low heating and cooling load, be flexible with people so they can use those energy efficient multi-zone systems. So if you're building a small townhome or any small home where the heating and cooling load is under 24,000 BTU, you can go a little lower on the HSPF. Air to water heat pump for heating and cooling. Again, I haven't seen any builders in Washington doing that lately, so I'm not going to spend any time on it. Oh, take a look though here. If you're a multifamily builder, you got 1.5 points for fuel normalization for using the multi-zone heat pump system. 3 points here. You only needed 4.5 points. So you're done if you're doing multifamily right there. Footnote A is electric resistance supplemental for small rooms. Like if you have a laundry room that needs heat, you can use a 0.5 watt per square foot. That was under our current code, and that will also be available under the new code. This is a new item under the new code, and it's a bit tricky. They are offering a half an energy credit for an Energy Star smart thermostat. Sounds great. They're pretty cheap, but the Energy Star smart thermostats are good if you have an old single speed or 2-speed low efficiency heat pump or gas furnace system. The high efficiency variable capacity heat pumps have really good control logic built in them. They do not benefit from a smart thermostat, and they actually may go down a little bit in terms of energy efficiency. So the only way you can claim this credit for the smart thermostat is if you're using a low efficiency 1 or 2 speed heat pump system or gas burner. So this is not really going to apply to most builders in most situations. Industry has been, shall we say, negotiating with Department of Energy and Energy Star for a long time on this Energy Star smart thermostat issue with the new variable capacity heat pumps. And just last summer, they issued a letter acknowledging that high efficiency variable capacity heat pumps do not benefit from Energy Star smart thermostats. So in Washington, most of the country, most of the world uses ASHRAE ACA design temps. Washington State, I'm not sure why, created their own design temp table. It's pretty close to the ASHRAE ACA design temps, a little more conservative in some areas, but those are the design temps that we have to use in Washington. And when you're figuring out if you need to use a cold climate heat pump or not, this is going to become very important. So you make sure you can get those energy credits and don't get questioned on it. Largely speaking, Seattle, Bellevue, Tacoma, Edmonds are 24 Fahrenheit and above, where you're going to have the option to use a standard heat pump or a cold climate heat pump. But as soon as you get over to Kirkland or Redmond, down into Kent and most of those outlying areas, your design temp is going to be 23 Fahrenheit and below. So if you want to get those energy credits or the high efficiency heat pumps, you're going to have to make sure you use a good cold climate heat pump. This is kind of the definitive list that we use as the state reference here. Many manufacturers have products on here. It's the NEEP cold climate heat pump list. It's very easy to find if you do an internet search, and you can see the little section here with the hyperlink. I'm not on the website, but if I were, you would see an active hyperlink here. We click here to access the list. It's open access. There's a lot of different ways to filter it. It's pretty user-friendly. Couple things about the NEEP cold climate heat pump list. It is a wide range of products in there. This is approximate, not precise, but I will tell you that minimum heat output at probably 17 needs to be about 75%. That is not a very high bar to hit in terms of cold climate heat pump performance. So I don't want any builder or HVAC contractor to think that just because a heat pump is on that NEEP list, they're going to get 100% of the heat at their design temp or where they're building their home. You still have to be careful there. You have to do proper heating, cooling load calcs, and then you have to do proper manual S selection to derate for whatever your design temp is. I'm a little concerned that could be tricky for people, but this is a great list. It is a really good step forward, and it's a great place for us to start. This is what's called a base pan heater. If you're in a cold area, most likely your heat pump's going to need it. One thing that everybody needs to be aware of is the NEEP specification does not require that you put a base pan heater in your heat pumps. So if you put a cold climate heat pump in here that's on the NEEP list, but it doesn't have a base pan heater and it's really cold in the winter and your outdoor unit turns into a popsicle, you're going to have problems. The reason I say that is when people are looking for NEEP certified cold climate heat pumps, you really need to be aware of these nuances so you can design it right. Almost all of our cold climate heat pumps, we pre-install the base pan heater in there, so you don't have to get that as an accessory. For most manufacturers, a base pan heater is about $150 to $400, depending on the size of the system. So if you're comparing a high quality heat pump that's $200 or $300 more, but it has a base pan heater in there, compared to a less expensive one that doesn't have a base pan heater that you need to get. Be aware of that. Okay. Under the old code, deeply buried ductwork got you a half credit. Under the new code, that's going away. The credit for ducts inside conditioned space is still there, but it's changing from 1 credit to a half credit. Washington State is really encouraging everybody to move their ductwork inside conditioned space. I think all builders and HVAC contractors should assume we'll continue marching down this path, and they need to figure out how to get ductwork inside conditioned space eventually. By the book in the code, all system components must be inside conditioned space. So that means your air handler. So if you're using a central heat pump, that should be inside conditioned space. Mostly around the Seattle area, we see people doing that. There are some jurisdictions where they're a little more flexible and they're still putting them in the garage. Technically, that's not the way it should be in Washington. This exception existed under the old code and it still exists under the new code. You can do, if you need to, you're doing ducts inside conditioned space, you can do 5 feet of supply ductwork or 10 feet of return ductwork. If you've got a tricky spot, you can run that outside conditioned space and still qualify. This is a big change in Washington State coming. Used to be code minimum was 5 ACH 50. Code minimum in Washington under the new code will be 4 ACH 50. So if you're already typically getting 4 ACH 50 or better in your homes, you're good to go. If not, you've got a little work to do. Aero barrier is one option, or you can work with your trades to figure out how to get a little more airtight. Verifiers are great resources for building science training. Also, Better Built Northwest can help with that training. In terms of ventilation, there are still energy efficient ventilation credits available under the new Washington State Energy Code. A lot of builders had been doing the whole home fan with 3 ACH 50. That was pretty easy to hit. That credit's going away. Under the new code, if you want to get ventilation energy credits, you can see there's kind of 3 tiers remaining here. 2 ACH 50 is going to, it's pretty tricky. That's an ambitious goal for a lot of builders with an HRV. I'm not sure if builders will keep doing that. I think most builders will just do heat pumps for space conditioning, heat pumps for hot water, and be good to go. Drain waste heat recovery systems are great. They were under the old code as an energy credit option. They're still there. In practicality, I don't see any builders doing it. And it's certainly not the least expensive or easiest way to get energy credits. The heat pump hot water heaters are still low-hanging fruit under the new code. You can see the tier 1 that I don't think many builders were doing is going away. The tier 3, which is what most builders are doing, is still there. The tier 3 split is basically a sand end system. Not too many builders doing that. This is the new one here, and I know Sonia's excited because we're going to have Gary Klein coming to the Built Green conference here in fall. But Gary Klein has been a building science proponent for what's called compact water design for a long time. And we embrace that in the new Washington State Energy Code. I think for builders that are doing small homes and apartments, this will be a fairly easy option to get. In large homes, it's going to be a little trickier to get this. Essentially, it means you bring all your plumbing fixtures close together, so you have a smaller water system and a smaller hot water system. Gary's proven that there are some savings in terms of energy efficiency and also in terms of water conservation. So it's a great strategy. The one trick on this is in order to make sure that everybody's doing a little work to get their energy credits, you have to have at least 1.5 bathrooms in order to be eligible for this credit. There we go. This is the NEA heat pump water heater list. It's been around for a long time. It's how we find qualified products to get those energy credits in Washington State. Solar is still an option to get energy credits here in Washington State. One of the good things they changed in the code for the next cycle is instead of being 1 credit for 1,200 watts, you can now get credits in smaller increments. So you can get a half credit for 600 watts. And if you're a builder who needs just a half credit to get all your credits, this might be an easier solution here. The Energy Star appliance package path is still there. If you do it, you have to provide all the appliances. They do not require that your dryer is a ventless dryer, but the Energy Star most efficient dryer list that happen to be on that list, I understand are all ventless dryers. So it's a bit of a misconception, in my opinion. Our new code is a gas ban. In my view, that is really not true. Builders can still use gas if they choose to. You can have gas for cooking. You can have gas for barbecues. You can have gas supplemental heat systems. So we have not banned gas in Washington State. The code definitely is encouraging builders to move away from gas for their major mechanical systems, though. On the right here, you see a picture of a great electric fireplace. On the left, you see a picture of a great induction cooktop. We're seeing more and more builders go to this, then they don't have to bring gas in. Okay, HSPF 2. All of our state code for heat pumps has HSPF minimum requirements to get those energy credits. It is kind of a perfect storm this year here in Washington State that we have the new code coming, and there's also a federal transition to what's called HSPF 2. That transition date was for all systems manufactured on January 1. Wherever it was manufactured, this affects all heat pump manufacturers, by the way, for space conditioning equipment. And those products were shipped from factories, and now we're starting to see those in warehouses, and I've seen 1 or 2 out in the field. But that transition is actually happening in the last half of this year, that we're going to see this equipment out there in the field. And the reason why it makes it tricky is our code specifies minimum efficiency requirements with HSPF 1. So you can see on this yellow sticker here that a lot of people are familiar with, the only way to tell that you've moved from the old HSPF rating system to the new HSPF 2 rating system is right down here, and it's kind of in small print. I will tell you the new HSPF 2 testing protocol is more realistic and it's better. The way they did it before was kind of not a real world static pressure for all the ducted systems. This is a much more realistic energy efficiency measure. So in the long run, I think we're all going to be better off with it. In the short run, it's going to be more growing pains as we make adjustments with our new code and with the HSPF 2. This is one of our submittals. All manufacturers of heat pumps will be similar. The test labs have been overwhelmed. The manufacturers have been overwhelmed getting all the HSPF 2 ratings out. We are about 80% of the way there now, and hopefully we'll have that done soon. It is pretty similar for a lot of the other manufacturers. This submittal document, if you look down here in the efficiency section, you can see HSPF, and that's 4, meaning climate zone 4, or HSPF 2, which is the new one for climate zone 4. This is anomalous here, and it may actually be wrong. It's not 9 and 9. It should be something like 9.5 and 9, because the new HSPF 2 scheme, the numbers are pretty much going slightly down. For all the ducted systems, it's about a 15% reduction. For the ductless systems, it's about a 5% reduction. And you'll see an example of that in the next slide here. So Washington State gave everybody what they call a crosswalk, and Washington, Oregon, all the states that have minimum efficiency requirements for energy credits. In Oregon, they do it as a required extra option. You have to use a 10 HSPF minimum heat pump. Washington State came out with a crosswalk document that has been ratified. You can find this on the State Building Code Council website. And there are 3 columns here. Ducted split, which is generally going to be a central heat pump that's fully ducted. And then over here on the right side where I'm hovering my cursor now is ductless systems, which will be either single zone or multi-zone ductless systems here, which is about a 5% reduction. This middle column is PTAX and package terminal heat pumps. We just don't see a lot of these in Washington. So you can pretty much ignore the middle column and focus on the central heat pump column over here or the ductless heat pump column over here. And you can see under old HSPF 1, if you were going for that 9.5 HSPF energy credit, the new number under HSPF 2 is going to be 8.1, about a 15% reduction there. For a ductless system here, if you were trying to hit 10 under the old HSPF, the new number you need to hit is 9.5. This affects all manufacturers. It is a federal change across the country. So I've got 2 tables in here. This is the part that's not entirely brand neutral here. This happens to be our heat pumps. What I can tell you with the transition to HSPF 2 is high quality heat pump manufacturers are getting rewarded for making better products. Low quality heat pumps are not getting rewarded when they do the testing and the numbers come out. In our case here, almost everything got rated the same or better under the new HSPF 2 testing protocol. This sheet table that you're looking at here is Washington State Energy Code 2018, because projects for the next year or so are still going to be building under that. So I've got this cheat sheet for our products here. I've also added into my cheat sheet table for our central heat pumps whether or not these products are on the NEEP cold climate heat pump list, which is going to become very important under the new Washington State Code. This here is under the new Washington State Code. When you use that crosswalk translation document here, you can actually see that we've got a lot of products that will meet the code and get everybody 1.5 points for fuel normalization. Also the 1 point for the high efficiency heat pump system here. And if you can do ducts inside, another 0.5 point. So this is kind of the cheat sheet for HSPF 2 under our new code that's coming. I've started a cheat sheet here for our products for multi-zone ductless systems here. These are the last few products we're working on getting the test lab data out on. Hopefully it will be out soon. Most of our products that check the boxes before for mini splits and ductless systems will still check the boxes going forward. And you can see on the smaller multi-zone systems here, they have lower HSPFs, but because we have that 2 ton and less relaxation, most of our equipment will hit that. And that has gotten us to the end at 1 hour and 10 minutes. So the timing is pretty much right on. I'm going to go ahead and bring up my gallery view here. And I think we can go ahead and open it up for questions. Sonia, I think there might be in the chat box if you want to read me questions, and then I'm okay if people raise their hands and ask questions too.
Yeah, I actually had a technical glitch and had to log back in, so I lost some of the chat history. I know David Barnes asked about something related to existing buildings. So I apologize to people who have put their Greg, you should be able to see them. So
Yeah.
There's only a handful of questions in there.
Okay. I've got the chat open here now. Let me look through it. Okay, I'm going back here. Okay. So this is David Barnes' question for everybody here. How can issues related to retrofitting for high efficiency be cost effectively mitigated? I'm thinking about multi-story residential buildings, including condominiums. I'm gonna say, I said this earlier, new construction is primarily my wheelhouse. I know some about retrofit projects. And the one thing I can say, if you're doing a retrofit or remodel project and you are replacing like for like, for example, if you have a old low efficiency heat pump that's 20 years old in your house and you want to upgrade that to a new energy efficient heat pump, that is not going to trigger a bunch of code requirements other than it, must meet electrical code and everything else. Like for like replacements are generally fairly easy. It's if you're doing a deeper remodel where you're moving walls around, changing your mechanical systems, all the new work has to meet the new code. That can be a little bit tricky. And I suspect that varies from jurisdiction to jurisdiction. Multi-story buildings, like apartment buildings where they rent them, are really tricky because landlords generally don't want to spend a lot of money on their building. And what do they care if the tenants have high electric bills as long as they keep paying their rent? I used to do a lot of energy efficient lighting work, and I worked with Tacoma Power. We got a hold of a very large landlord down in the Tacoma area, started doing energy efficiency measures through all their buildings. And what they realized is because they were getting weatherization and energy efficient lighting, they were actually improving the value of their buildings. So some multifamily landlords may see doing this work as a way to improve the value of their property. Some may not buy into that.
Yeah, and I think some of this will also be addressed through, while there may not be a market incentive for the existing structures to retrofit, we do know the clean building standard for the larger multifamily structures will be in the future required to not only show their performance and get it measured, but also look at reducing if they are beyond certain efficiency parameters. And so that will come down the pipeline. And I think more education will be offered in some of those spaces going forward on how we're going to retrofit these. Currently, from my understanding, most, like Greg said, the code is if it's an existing structure, you can do like for the code. But with the green building standard or the clean building standard, that will definitely change some of those dynamics for larger structures in the future. I also, go ahead, Greg.
Oh, I was just going to say the other thing to look at, my main focus under the new IRA package has been the 45L tax credits. I haven't taken a hard look at the retrofit energy efficiency credits that are coming, but I suspect some of that may apply to multifamily. So if you're multifamily property owner or your city official who's working on energy efficiency for multifamily projects, I would take a hard look at what IRA offers.
Yes, there are some many tax credits available for existing structures. Some of the resources Built Green has put together has been primarily focused on single family residences, but there are some in the commercial space offered by both utilities as well as the federal government IRA tax credits. I did see one comment earlier also, Greg, who somebody had asked about which HVAC designer you were referring to earlier, and
Yep.
if you would be willing to share.
Of course, I have about 5 that I like to use, and it depends on what type of project it is. For the high-end custom stuff, I have one HVAC designer that's really good. I actually have 2 that are really good at that. I have 4 or 5, but it depends upon the project. So I will tell you that in the Seattle area, I use Balance Construction Consulting. Aaron Barnett's been around for a long time. My email is on this slide here. If you send me an email, I can make you an introduction to any one of the HVAC designers out there. Down in Oregon, I work with Earth Advantage HVAC Design sometimes. Tyler Moffitt's one of the big verifiers and engineering shops down there that will do HVAC design work. For some builders, larger builders that use Arxis for verification services, they can also do HVAC design. So send me an email, tell me what kind of projects you're interested in getting HVAC design for, and I can make a good introduction.
Thank you. We had a couple questions related to the Berkeley decision and how that's impacting our energy code and the direction the SBCC is sort of considering that decision in terms of the Berkeley kind of gas infrastructure ban on new construction. Can you share anything about how that's, if you can, since you are part of the tag?
Yeah, let me talk to that. And I'm looking through the chat box here. Jeff Oslan, thank you for putting your comment in here. Jeff says that they can do high performance HVAC design. It's madronabuildingperformance.com. And that's great. Jeff, I would actually love to meet you one of these days because I'm always looking for good HVAC designers.
Jeff is also a Built Green verifier. He's located in the Whatcom County area.
Yep, that's fantastic. I know many of them, but I do not know all of them. And I, send different projects to different people because they all have their niches. So back to your question, the Ninth Circuit decision was Berkeley, and it actually involved a restaurant where they basically said no buildings can use gas, and it was more of a full gas ban. The Washington State Energy Code, not banning gas in new construction, like I said during the presentation. There will be a big tag call coming this Wednesday. It is open to the public. So if you are deeply interested in this issue and you have 4, 5, 6 hours to burn on Wednesday, you can dial in on the tag call. They're kind of interesting in a very democratic kind of way. It's been, I call it sausage making for sure. I think when people call it a full gas ban, that's not accurate, but that is the concern in Washington. I have a lot of thoughts on this, and I'll try and keep it short and simple for this audience. The concern everywhere has been what's called federal preemption. That's the legal standard that is used. However, in Washington, we've been using the fuel normalization scheme for at least 3 or 4 years, and I think longer than that. And under our fuel normalization scheme, we've been encouraging low carbon, low energy buildings, both on the residential and the commercial side. We are continuing down that pathway because we have sustainability goals for both energy and carbon in Washington State. It will certainly be an interesting discussion this Wednesday. We do not have a gas ban in Washington, in my opinion, but we'll see how this gets treated. And the last thought I'll throw in there is the gas companies in Washington and the Northwest were very involved in all of the energy code discussions. Some of them are on the tag. We actually approved under the code gas-fired heat pumps. They're not quite ready for prime time, but there's this whole industry making energy efficient gas heat pumps that may be ready for prime time in a few years. So that is actually permissible for space conditioning when they are ready for prime time. So the gas industry was fully part of the discussion, and I think we tried to find some good compromises there.
Another question that has come in, any credit for modulating microelectric boiler systems, in parentheses, HydroShark, and hot water radiant heating as primary heat source and or supplemental?
So I don't know a ton about the micro systems, but I will go back here. I'm going to jump back into my slide deck. Let's see if I can get this moving. Because I skipped through it. Not many builders do it, but it is actually an option that is possible under the code. Let me get to that one here. Almost there. That's it. Option 3.8, air to water heat pump for heating and cooling greater than 3.2 COP. So if you use an energy efficient air to water heat pump and use it for space conditioning, like a Chiltrix, you can get an energy credit here. One of the interesting new elements of the discussion in the state code tag calls was these extreme heat events that we've been getting because of global warming is a game changer. Both Washington and Oregon are looking at the life safety issues related to cooling when we have extreme heat events. So historically, and even by international codes, heating is required. Air conditioning is optional in most areas, but there was some language, and you can see here, this is new language, and that's why I have the red arrow. If you're gonna do an air to water heat pump, it has to deliver heating and cooling. I do suspect somebody, we don't see a lot of radiant heat systems. Chiltrix can do both heating and cooling, and that's a good energy efficient system. I suspect somebody's gonna say in a custom high-end home, I want radiant heat. Okay, get an energy efficient air to water heat pump system. For cooling, I'm gonna do a ductless heat pump to get my cooling. And hopefully the code official, as long as it's energy efficient heating and cooling equipment, will say, that meets the spirit of the code, let's do that.
Great. Can you make a comment? I've heard a proposal where it was essentially you would use something like a sand-in heat pump for your water heater, use a hydronic radiant heating system for your heating and hot water needs, using that one sand-in heat pump, and then adding a chiller coil, and sorry if I'm not using the correct technical term, on the HRV if they also had an HRV to provide the cooling. And would that suffice under the new code?
You know, that's not going to be a common solution. Maybe a few high-end custom homes built by energy efficiency geeks will try something like that. I know there are some passive multifamily projects built in Seattle where they did the Zender HRV and they did a fan coil right after it for heating and cooling because they had crazy low heating and cooling loads. That works in a building like that, but that's not going to be a common situation. I think if you find a builder who wants to do that, they're going to have to take that up on a case-by-case basis with their code official. It's not a standard mechanical solution. Did we get through all the other questions in the chat box?
I think so. Well, Kent did ask if you could summarize why the delay in the code happened, the code adoption.
I have been involved in code stuff since like 2012-ish. As a matter of fact, new codes cost me my job and I had to go find a new job when I was doing energy efficient lighting. I think every code cycle we've had at least a small delay just to give people a little more time to adjust. There was one request for delay by one of the big builder groups in the state early on that the State Building Code Council said no to, but about 3 or 4 weeks ago, they want to make sure we have a full and fair discussion of this Berkeley thing and whether or not it applies to us. So they did do a delay until October 29th of our code implementation. The reason the State Building Code Council gave is to make sure we can have good discussion of the Berkeley situation. And I'm glad we're going to have that discussion and make sure everybody gets heard. But not a gas ban what we're doing here in Washington. We're just moving to meet the state energy goals and carbon goals.
Thank you. So I don't have any more questions from the chat that I can recall or see. So I do want to kind of just step to the right a little bit and address some of the concerns we have heard about the current code. So jumping back to the current code of 2018 Washington State Energy Code, and some of the concerns or struggles that some of the the townhome builders have been finding with the their HVAC designs, or trying to meet code through, you know, these very limited footprint sort of vertical stacked units. Could you kind of walk us through sort of some cost effective options, again, under the current code we have now?
Yeah, I've got to say the 3-story tall skinny townhomes are really challenging. I personally, you know, you have a lot of floor space dedicated to stairways and getting up and down in your home, and when you're paying $200, $300, $400 a square foot for your real estate, that I have a hard time with it. But it's what we build in Seattle because it's what the codes are encouraging, and it's kind of a way to get a lot of homes up in the space we have available. It's my belief, there's a big national builder that I looked at about 2 months ago, where they're doing that option to use the mini split in the largest living area, plus an extra mini split in the master bedroom on the top floor, and electric resistance in all the small rooms. That's probably the most cost-effective way for builders to do it and make sure the entire home is comfortable and they're not breaking the bank. So I really like that strategy. I think if I were building the 3-story townhomes all over in Seattle and Portland, that would be my first choice.
And then I think the other big thing is currently Built Green requires for 4-star certification, if they are doing, they're falling under the green building standard and requiring, or elsewhere seeking 4-star certification under Built Green, they're required to get 2 additional credits. Do you have any comments on where they can find those 2 credits?
The truth is, it's different for every builder. I have a big builder I work with down in Southwest and Southeast Washington that has been doing HRVs for a long time, before it was encouraged by code, because they believed in the energy efficiency and they believed in the improved indoor air quality. So when the last code cycle hit, for them to go to a more airtight home, plus the HRV that they're already using, was a pretty cheap way to get energy credits. For the average builder, you know, use heat pumps for space conditioning, use heat pumps for hot water, and then you may, in these 3-story townhomes under the new code, be able to get that compact water design credit. That might be the least expensive way to get a half a credit there. Townhomes, it's really hard to get space for solar, but now that you only need 600 watts, not 1200 watts, that is probably 2 panels. So there's a lot of these townhomes that may be able to fit 2 or 3 panels on the roof. That's worth looking at. I will also tell you, I've got a builder in Eastern Washington that, I want to say this carefully, energy efficiency and sustainability may not be their highest priority, but they have discovered that solar on their roofs is really sexy and it helps them sell homes. So even if it's not truly your most cost-effective option, solar looks really good and, you know, looks green, and everybody wants to have a Tesla parked in their driveway. Also in townhomes, the drain waste heat recovery system is actually not as bad as people think it is. I suspect plumbers are pricing a lot of fear factor in on that. That's definitely worth looking at. One more comment as I'm thinking about this. I know when you're selling homes, granite countertops, pretty fixtures, and all of that superficial stuff is what people really want to see, and they're willing to pay for it. But in terms of building a high quality home that's going to be healthy and energy efficient, nothing beats good ventilation. So, and I do have 1 or 2 builders that talk to home buyers about, you know, improved indoor air quality and health. And I think in the last 3 years, where we've had the extreme heat events, the forest fires and the smoke that's been very significant, the air quality events, I think it's easier than it's a lot easier for builders in Washington now to sell good indoor air quality. Which means good HRV, good airtight home, and maybe a little bit of filtration. So I think that may or may not always be the most cost-effective way to get those energy credits. But if you're building a high-performance home and you're not talking to home buyers about what sets you apart from the average builder, why do it? And I think high-performance builders can get a little more money for their homes, and I think they have a little better resale too.
Well, thank you, everyone. We will be, unless we'll stay on just for a couple minutes in case some last minute questions come in. Greg shared his email address. You can contact him directly with any questions or follow-up. We will be sharing his slide deck with you, as well as a recording of this video within a week or two once we are able to process that video. And we will also be including a survey which helps us really direct what educational offerings we provide you through Built Green, as well as feedback to our instructors who are always looking for a good comment or support. Please do fill out the survey. And again, we will be offering this sort of education in depth at the Built Green Conference. We're actually focusing on a Code Academy track, and we'll offer a lot of great content on the 2021 code changes at the Built Green Conference on September 14th. So if you want to save that in your calendar now, please do so. Tickets should be on sale for that in July, and you'll see that in the Built Green newsletter if you are subscribed to that as well. As Greg mentioned, Gary Klein is going to be a special guest who will be talking in depth about that compact water design that is sort of a win-win for everyone in terms of energy use, water savings, and comfort for consumers. So that's another way, again, to get credits that are, good design for your projects. Greg Davenport will also be speaking again at their Built Green Conference. So if you like his content, please come to that as well. And again, thank you everyone for your time today. We'll be sitting here for just a couple minutes, and enjoy the rest of your day. And if you are celebrating Juneteenth, please enjoy that as well.